Okay, today's lecture is going to be much more conceptual than anything else this semester. I want to talk about like the relationship between correlation and causation, or causality. Okay, and so this is important. Again, it's not going to be a technical lecture. I'm not going to be doing math. I'm not going to be showing you all how to do things in Excel. I'm going to be talking more conceptually about what goes on in statistics. Okay, so again, correlation and causation. A lot of the questions that we're interested in answering in statistics have to do with what is the effect of X on Y, okay? We're really interested in looking at the effect, the causal effect. How much does a change in X cause a change in Y? And so we really want to know about causation. Okay, now you've probably heard the saying a dozen times, well, correlation doesn't imply causality. Okay, the truth is what we measure is always more or less a correlation. And observing a correlation, quite correctly, doesn't tell us what causes what. And so that's going to be the essence of today's talk. Now, I said I wasn't going to do math, but I lied a little bit. Remember that our econometric model that we try to estimate is, we believe that, the true relationship between two variables can be described more or less as y is a function of x, okay, plus some other factors. Okay, UI stands for those other factors, the unobservables. And we have a way of estimating the coefficients, but the thing that we're most interested in is the beta 1. That's interpreted as the, beta 1, we would like to interpret as the effect of x on y. Okay? So, an example that I've given in class is estimating the relationship between a worker's earnings and how much schooling they have. And the reason that we're interested in that relationship really is because we think that changing schooling will change a worker's earnings. Okay, we think that schooling is the cause and earnings is the effect. Now, okay, when it comes to actual calculations, the way that we calculate beta 1 hat is the formula covariance between x and y over variance in x. Okay, I've given that before, but I'll even rewrite it one way. We could just as well, changing some terms around, describe this as the correlation between x and y times the standard deviation in y over the standard deviation in x. Okay, would be a mathematically equivalent way of writing this, and the only reason I do this is to highlight that, yeah, it is a correlation. Literally what we are measuring is a correlation. Early on in the class, if I gave a letter to signify correlation, it's the letter R is always used. The letter R is used for correlation. It's originally what, this idea of correlation is what Galton referred to as a regression factor. R stood for regression. Regardless, today's terminology is correlation. So what we calculate for beta 1 hat is fundamentally a correlation between x and y, just scaled by the relative standard deviations in x and y. The main thing is our estimated effect, that's with air quotes, of x on y is always a correlation. And what was that cliche? Correlation does not imply causality. Okay, so let me talk about some potential research questions. First two of these come from my previous job working with North Carolina Public Defense. A question that was very relevant was, do clients, that is, people who need a public defender, defendants, do clients get better results from a public defender, that's someone who works full-time for the state of North Carolina, defending people who can't afford an attorney, or do they get better results from a private defense attorney? Like someone who's doing their own thing, runs their own law practice, but takes defense cases for people who can't afford it on the side. Okay, and let me just make a note. In North Carolina, this is a county by county distinction. Some counties do it one way, some counties do it another way. Okay, so until 2 years ago, Alamance County, where we are right now, correct? We're in Alamance County? Yeah, okay. Alamance used only private attorneys, private defense attorneys to represent indigent clients, people who couldn't afford an attorney. That was changed. Now there is a state office in downtown Graham, which is staffed with public defenders who handle those same cases. And the belief is that those public defenders employed by the states will deliver better better results for clients. Okay, that's something that in fact I worked on in my previous job. Another question along these lines is, when an attorney has a large caseload, a large number of clients, do results get worse for the clients that they have, right? Basically, do they get overloaded with too many cases and they don't have enough time to give each client proper treatment? So what is the impact of having a large number of clients on the outcome for clients? Okay, some other questions. Okay, here's one. Does alcohol consumption impact academic performance? Okay, I bring this up because it's something that a former student of mine did research on. Okay, and at the same time, this question, does alcohol consumption impact academic performance, it stands in for a lot of other questions. Like, you could replace alcohol consumption with a variety of other, like, I would say, variables or factors. Like, does attending class impact a student's academic performance? Does being here actually make you do better in the course? Okay? I'll talk about why these things may or may not be correlated for the reasons that we expect. I would also say this also stands in for things like, does alcohol consumption impact a worker's performance? Okay, the same issues arise. So I'm putting up questions where you could tweak them a little bit and they cover a lot of ground. Okay, here's another one. Does being left-handed impact a worker's earnings? Left-handed or a variety of other work characteristics. Do they impact a worker's earnings? All right, now we're always talking about measuring the impact of X on Y, okay? Almost always our research questions are about linking an x variable to a y variable. And I really try to stress that when I present the regression model. There are some explanatory variables, and we believe that they are impacting an outcome y. So in these examples, there's an x, every example that I gave you all, there's an x factor and a y outcome, okay? So like x factor, having a public defender office. Oh, sorry. We have to actually measure these outcomes in different ways. So one question I had was, does, so along the lines of like, does a public defender cause better outcomes than a private attorney? Okay, you have to name some type of outcome. One of the things that people are interested in that's very easy to measure is pre-trial detention. How long you wait in jail before your trial. And, you know, this is, okay, just one of the measures of an outcome that might differ between a public defender and a private attorney who's representing indigent clients. Or, you know, another situation like estimating the impact of attorney caseload on client outcomes. And one measure is how many hours are spent on each client's case. Okay, alcohol and academic performance, you know, measure students' alcohol consumption in some way, measure academic performance, grades in class, something like that. Okay, and then finally, hand preference and income. I mean, I'll keep that simple. Okay, but there's always this X factor, like an X factor impacts an outcome. Okay, we're always setting up our research questions that way. Okay, as I said, when we estimate the model, like those are the y variables we would be putting into the models. Like y variable is a measure of academic performance, GPA. The x variable is alcohol consumption, number of times you drink in a week, or number of drinks you have in a week. Okay, we estimate regressions very often. I've said before, like this is our main work tool in statistical analysis, linear regressions. And they're based on calculating a correlation, and as I said, correlation does not imply causation, or correlation does not imply causality. If I say the word causality or correlation, those mean exactly the same thing. Okay, correlation does not imply causality. Okay, so why do we care about this topic? You've heard that cliche before, probably. Why am I bringing it up again? Well, I want to add two important thoughts to that. One is causality does imply correlation, okay? So this is important to remember. Like, don't be dismissive of a correlation simply because, well, we don't know that it's causal, right? People use this line, correlation does not imply causality, to shut down a statistical argument. But let me say, if there is an effect of X on Y, we expect to see a correlation between X and Y. That's why we use regression as our technique. So a causal relationship implies we would expect to see a correlation between the variables. Okay, so this is important to keep in mind. Like, don't be dismissive of correlations. In other words, a correlation is suggestive of causation, or if you observe a correlation between X and Y, it means that X could be causing Y. Maybe unless you have a better explanation. right? And so at that point, I acknowledge that we might find a correlation. One reason for a correlation is because X could be causing Y. But then it's also important to think about what else could be going on. And why is it the case that we could be observing this correlation if it's not a causal relationship? So this will give us better interpretations of what is happening in our data. So I'm going to try to expand your critical thinking skills beyond just being skeptical about research because correlation doesn't imply causality. Think about what else could be going on. And we can typically say that there are just a handful of things that contribute to correlation aside from the causal effect. Okay, so why does causality matter? Okay, let me make sure. Just double check something. So I want to kind of talk about why causality matters, why we care about this, and then when we should have concerns about causality. Okay, so the types of challenges or the other things that are going on, I'll give you names for the three things that can contribute to the observed correlation between two variables aside from the effect of X on Y. Okay, the types of challenges that we encounter when we're trying to interpret data. If we're trying to interpret our results as this is the effect of X on Y, there are three challenges that we could bring up, okay? Or to put this another way, suppose you do some research, you're trying to establish that variable X causes variable Y. And you look at your data and you measure a correlation, okay, and you claim, based on this correlation, I believe X causes Y. There are three challenges to that position. And really, again, only these three arguments that can be used to shut down your claim that you found an effect of X on Y. Okay? And I'll give them names. The first is reverse causality. Instead of X causing Y, instead of X causing Y, it could be the case that Y causes X. Okay? So that's the story of reverse causality. The second is unobserved differences between people with different values of X. And the third is something about sample selection. How your sample was generated and the fact that the observed correlation in the sample is perhaps created by the sample selection technique. Okay, how your selection was how your sample was generated. Remember, for example, I've talked a lot about telephone surveys, right? When pollsters are trying to figure out which candidate voters like, they use a method to collect their sample, okay? Usually step number one, they go to the State Board of Elections, and they ask for a list of registered voters and their telephone numbers. Second step, they call those telephone numbers, and if they get a response, they ask the questions. So there's a process to collecting the data. Now, that process generates a group of people who are different from the actual voters on election day. And that process of selecting the sample, in some cases, creates a relationship between variables that would not be true in the overall population. All right. So, why do we care? Okay. Well, why do we care about like really identifying whether X causes the effect? Often, like we want to, well, so we might want to know simply what is determining the outcome. You know, I brought up an example in class on Wednesday where we looked at the relationship between gender, being female, and a worker's earnings. And what we saw in the data was very clearly, just off the top, women in that sample, the average wage of women in the sample was about 40% lower than the average wage of men in the sample. Okay, so this might be important, but we want to know, is it really gender that causes that, right? And I brought up the possibility that the difference could be due to other variables like education or years of work experience, okay? That is actually those factors causing the difference in wages, okay? And why do we care about, like, is it actually gender itself or is it experience and education? Well, the solutions to wage inequality would be different. If it's actually gender itself, if it's just the case that employers are paying women less for doing the same work, then I suppose the solution to gender, or like to wage inequality would be better enforcement of laws against like sex discrimination in the workplace. Okay, but on the other hand, if the reason women earn less than men is because women have less work experience or less education, doing something about enforcing anti-discrimination laws isn't going to change that. The solution would be policies that cause women to have equal work experience as men, or to pursue equal amounts of education as men. So if we want to correct the gender inequality in earnings, then the solution is going to depend on what is actually causing it. So we want to know, like, whether this important outcome, an observed earnings gap, actually comes from gender or from something else. Okay, so along the same lines as what I just said, the effectiveness of the intervention, right? If we want to intervene in a situation like that, like if we believe that society should correct the problem with some type of intervention, some type of policy, we need to know what is actually causing the result. You know, another example that I gave was the difference between one type of defense attorney or another type of defense attorney. If we want to improve outcomes for clients, like by changing, as we did as the Department of Indigent Defense Services did for Alamance County. Like, they enacted a policy to change the way that attorneys were being assigned to clients. And the effectiveness of that, whether it actually is going to help clients, depends on whether the type of attorney really caused the difference in observed outcomes. Okay. And also, for the sake of research and evaluation, if we want to do a good job of understanding a problem, thoroughly understanding a problem, thoroughly researching what are the causes of gender differences in earnings, we need to think carefully about whether we are identifying causal effects or just something correlated with what causes the effect. Okay, now, I'm going to say, this is more an issue in the social sciences, which include business. Okay, social sciences like economics, sociology, psychology, political science, government, business. Like when we're talking about people and what they do in the real world, as opposed to the physical sciences. So people who do research in the physical sciences trying to figure out the effect of some medication on a health outcome, they use different methods, and they don't have to worry about causality as much as we do in the social sciences. So this problem of identifying causality is primarily something that we encounter in the social sciences when we're working with real-world data, okay? Because people make decisions based on their unique circumstances, right? If we're talking about people in the real world, that's what social sciences are. The people are making decisions based on their circumstances, and presumably, like often, people are being rational. So if they're making different decisions in the same circumstances, we have to wonder what is going on. Okay, like the example of alcohol consumption and academic performance of students. Okay, I put that down because it's something that might hit a little bit closer to home. You all are students, and students are notorious for consuming alcohol. I'm not saying that you all specifically are the ones who are notorious for consuming alcohol, okay? Not at all, okay? In fact, I'm saying people make decisions based on their unique circumstances, and presumably people are rational. So you have a friend probably who like loves to go to every keg party they hear about, right? Whether or not they're invited, they go to the keg party. I'm embarrassed to say that when I was in college, my nickname was Leech, which came in part from the last name Litch Tyler. But if you ask the person who gave me the nickname, she said, it's because of the way you stick onto a whiskey bottle. It's like you put it in your mouth and you just like clamp down on it and suck it dry. Okay, that was, okay, apparently my reputation. There are different people though. Some people are more conscientious and have different drinking patterns. Presumably there is a reason why they do these things. Okay, or if we want to switch to a different question, like what's the impact of attending class on academic performance? Okay, well, I can look around this room and see there are many people who made a decision today not to attend class. You all decided to attend class. Okay, I don't think this was entirely random. I think you all had reasons why you wanted to attend class that were different from the people who are not here today. Okay, I know it's kind of awkward to talk about them not being here, but you get, like, maybe you all have different attitudes, right? If I were to look at the impact of class attendance on grade, okay, I'm sure I would find that the students who attend class regularly do better than the students who don't attend class regularly. But is that because y'all are nerds who care about your schoolwork more than the folks who skip class? Possibly. Or something like that, right? You might be generally more conscientious students. And maybe that's the reason that you perform better in class. I assume that explanation makes sense, right? Or it could be something else. I mean, it could be that you are attending class because you did poorly on something in the past, and that has changed why you attend class. Or it could be that you attend class because you are involved in athletics. Being involved in athletics could go either way, right? Could result in attending class more often or less often, depending on rules and schedules and things. But again, that's something that differs between the students who are in class and the students who are outside of class. There are reasons why people are attending class as opposed to not attending class. Okay, so this relates, I guess, to, okay, and now I'm going to go next into like the ways that data are kind of generated and collected. I want to make a big distinction between two types of data: experimental data versus observational. Okay, experimental data are the type of data you think about coming out of a science experiment. But if I were to okay, experimental data, the X values are controlled by someone or something external. Okay, so think of the classic lab experiment. Maybe even a medical team is trying to evaluate the impact of some drug on a health outcome. Okay, experimental data are when the researchers randomly assign people their doses. Okay, control group, you get a placebo. Treatment group, you get a full dose. Second treatment group, half dose. Okay, placebo, full dose, half dose, etc. Different people are assigned their X values by someone external, like the researcher. Okay, those are experimental data. Got it? Okay? As opposed to observational data, where the values of X are determined by individual circumstances. Okay, now, think of a different way we could collect data on drug use and health outcomes. Okay, drug use, like pharmaceuticals, sorry. Okay, which would be, we interview you all about your health outcome and how much of the drug you take. Oh, and I ask you, do you take this medication? And you say no. I ask you about your health, you tell me. I ask you about medication, you say yes, you take it. I ask you about your health. I ask you, no, you don't take it. You tell me about your health. Okay, if we look at those data, those are not experimental. The values of X are essentially determined by your unique circumstances. Presumably, your doctor was not just randomly assigning you this drug. There's a reason why the doctor prescribed the drug to you, but not to you. Okay? Does that make sense? Okay. That gets tricky because usually the thing that determines whether the drug got prescribed to you is your health, right? And doctors are actually prescribing drugs to unhealthy people, typically. Okay, so here's a preview of what we might see in observational data. It could be the case that like a drug is very effective at treating some outcome, like giving you better health, and yet we observe that the people taking the drug tend to be in worse health than the people not taking the drug. Okay? Like if you look at people taking blood pressure medication, what you would likely find is that people with high blood pressure take blood pressure medication. Right? Or if you look at obesity, you would find that the people taking anti-obesity drugs are fat, whereas the people who are not taking anti-obesity drugs are thin. Okay? If you were to try to look at the effect of taking the drug on health, it would look like the people taking the drug are fatter than the people not taking the drug. Actually, the opposite result of what the medication is intended to do. Okay, do you get the problem there? Okay, so in fact, the correlation between taking like what we might find in the experiment is that the correlation between taking the drug and health is positive, okay? But, right, because if everyone starts out the same and the researchers randomly decide to give the weight loss drug to some fat people and randomly decide to give the placebo to other fat people, they do the same with the skinny people, then we would expect to see a positive correlation between the drug and health. Taking the drug improves the health outcome. But what we find in observational data, these are real world data, just based on what we observe in the real world, is that taking the drug is negatively correlated with health. It looks like the people who take the anti-obesity medication are fatter. Okay, so so I want to kind of clarify, like there's different ways of collecting data, experimental and observational. The types of problems I'm talking about today show up with observational data, not experimental. As I said, define it. Like experimental data. So experimental data, just so you know, a couple of names for these. Like the ideal version, many people would say, like the ideal experimental data are called randomized controlled trials, RCTs, randomized controlled trials. Exactly the kind of thing I described with medication. There are a group of people in the sample. They are randomly put into a control group or a treatment group. Randomized and controlled in the sense of the researcher controls the amount of medication. So a randomized controlled trial. If you do a lot of data analysis, you will hear the expression that randomized controlled trials are the gold standard for identifying causal effects. Like if you really want to convince someone that you have identified something causal, you use a randomized controlled trial. There's also another type of experimental data that is popular among social scientists. These are called natural experiments, where some like something in the real world behaves like a randomized controlled trial, or something in the real world randomly determines the values of X for people, randomly influences the values of X for people. One of the great experiments, or natural experiments, looked at, okay, let me see, the impact of attending college on earnings. Okay, but attending college is not a random thing. Like, y'all made a choice whether to attend college, right? This isn't like your parents, well, unless your parents are like me. I'm very tempted with my kids to be like, okay, we'll flip a coin, you go to college, you don't, and we'll see if there's actually any benefit to college, right? I'm tempted to do that with my kids. If my wife would have given birth to twins, I really would have pushed for these types of experiments, but okay, fortunately she didn't. Okay, so college attendance is not random. Well, we do have, researchers did find a neat example of some randomness that came from the Vietnam draft. Okay, now this is ancient history. This is before even I was born. Okay, so like back when really your granddads were about college age, there was a war going on in Southeast Asia, and it was not very popular, and for some reason young men were not voluntarily signing up to go off to Southeast Asia to get shot at. Okay, so the government started drafting people. The way that they would draft people now, or call people up for the draft. Now, if you were called up for the draft, there were things you could do to not get drafted. And one thing was have a medical excuse. But another thing was being enrolled in college gave you a deferment until you finished college. Okay, so if you wanted to avoid being drafted, something you could do was sign up for college. Okay, get you a deferment. So President Bill Clinton famously did this. You know, he got called up for the draft, and he was like, you know what? I just enrolled at the University of Arkansas. Look me up 4 years from now. Okay, and so again, that was common. So what's relevant here is the way that young men were called up for the draft was based on their birth dates. Okay, all 366 days of the year were put into a random order. Okay, and so they literally wrote the days of the year on ping pong balls, put them into a big hopper, mixed them around, and started drawing them out one at a time. So it might have been like August 28th was the first birthday to be drafted, followed by March 13th, followed by February 12th. Okay, the days of the year were put in order to be drafted. Okay, so you knew at that point where you stood in the draft lottery. Okay, it was referred to as a draft lottery. You knew, for example, if you were born on August 28th, you knew you were first in line to go off to Southeast Asia unless you were enrolled in college. So if you had kind of been sitting on the fence about going to college, here was something that nudged some people over the edge into attending college. But if you were one of the last dates in the draft lottery, so I think like maybe November 4th was one of the last days in the original ordering. If that was your birthday, you could pretty much guess that the lottery was unlikely to impact you. Like, they would have to kill off all the other people before they get to your birth date. And hopefully the war would, be called off before it got to that point. Okay, so here was something that kind of randomly impacted different men differently. And so what researchers found was that the earlier someone was in the draft ordering, the more likely they were to go to college. So this really behaves like randomization, okay? Or, well, it is something random, and it determined how much education they got. So that's something that that statisticians, econometricians call a natural experiment. So two types of experimental data. Okay. Randomized controlled trials, natural experiments. Okay. Okay. All right. Now, moving on. As I said, the problems that we encounter are with observational data. Working with experimental data is fairly clean. So if you look at your data set and you recognize that the way the data are generated is an experiment, either something like a randomized controlled trial, or you could argue that it's a natural experiment, then you're fine with saying you've identified a causal effect from your correlation. However, when working with observational data, real-world data, there are really 4 reasons why we might observe a correlation between X and Y. Okay? 4 sources of correlation between X and Y. Okay, so first, causal. X causes Y. That's the thing that we're interested in. Okay? And probably we're estimating or studying this question because we have an inkling that X could be causing Y. So, number 1 reason we believe maybe X causes Y. The second thing that I want to bring up, reverse causality. Okay, so it could be the case that Y causes X. Does that make sense? Okay, the data themselves can't tell us which is really the X variable and which is the Y variable. So if we observe a correlation between X and Y, absent any other knowledge about the situation, it's just as likely that Y causes X as X causes Y. So, here, think of the example that I brought up where we're trying to relate a medicine to a health outcome. So we want to estimate the effect of some medicine so-called drug on a measure of health. So the health of patient I is a function of whether patient I takes a drug. Okay, so we might have different ways of measuring this, like BMI as a function of anti-obesity drugs, or blood pressure as a function of antihypertensives. Antihypertensives are drugs to reduce blood pressure, or depression as a function of antidepressant drugs. Okay, I mean, whatever you talk about, I mean, notice there's almost a pattern to the way the drugs are named, right? Anti-obesity drugs, antihypertensives, antidepressants. Okay, the drugs are intended to reduce these outcomes. Okay, these are intended, again, the drugs are intended to reduce the health problem but the truth is we would likely find a positive effect likely find a positive effect. In other words, the drug appears to worsen the condition, to worsen health. Okay. Again, in observational data. Okay. Well, I talked about this type of thing just a minute ago. This is what we would expect to find because because causation runs in both directions. But especially the process of how your doctor assigns the medicine to you, that's determined by whether you have the health condition. If you are not obese, you probably take 0 anti-obesity drugs. If you are obese, you probably do take you are more likely to take anti-obesity drugs. So it looks like these drugs are making people fat, okay? Causing them, or at least when you estimate this equation, health is a function of how much of a drug you take, it will look like beta 2, it'll look like this beta 2 hat is positive, right? Beta 2 hat is positive. Well, what that really means is you have a positive correlation. but not necessarily a positive correlation, but not necessarily a positive effect. Okay? Because again, the correlation could be running in the opposite direction. Okay. Second on my list of things to think about, okay, reasons why we might find correlation in the data aside from the causal effect of X on Y. There could be unobserved differences that are causing Y. So something unobserved that is associated with X is actually causing Y. Okay, so think of, let's see, think of the relationship between alcohol consumption and academics. Okay, and we're interested in studying that relationship, like how does drinking alcohol impact your academic performance? Okay, we will have problems estimating that if there are other factors associated with alcohol consumption that have their own impact on academics. Okay, so just brainstorming, like what types of things might pop to your mind? Like, is there something else that is associated with alcohol consumption that might actually be the thing impacting environment, or impacting academics? Sleep deprivation. Okay, so it could be that alcohol causes sleep deprivation, and sleep deprivation causes worse academic performance.
Yeah, you can't enter REM sleep.
What?
You can't enter REM sleep if you've had alcohol.
Okay, if you've had a lot of alcohol, you can't enter REM sleep, and so that's the real problem. Okay, yeah. What about, what else? Like, maybe think about, like, what are ways that drinkers and non-drinkers are different? The partiers and the non-partiers. Anything that on average would be different between the groups. Lack of hydration again could work, yeah, the same way as sleep deprivation. Okay.
So are you leading us to say, just like if you go to parties, maybe you don't put as much work into school? Is that what you're saying?
Attitude? Yeah. Okay. Maybe attitude is something that impacts alcohol consumption as well as academics. Right? Do you have a pro-academic attitude or do you have a pro-party attitude? Yeah. And that's something that, yes, could be sort of the source of the differences. and this is really the type of thing that I'd like you all to think about. Like, what is different between people with different values of X. Okay. Remember, like I brought this up with gender and wages. The women, yes, they had female and wages. Okay, it could be that being female is not the cause of the lower wages, but instead being female causes less work experience, and being female causes less education or more education currently. And those things have their own impact on wages. Okay, so it's some other factor. As I describe this, unobserved differences. Okay, now, unobserved. Some of these things are really, really hard to observe, like your attitude toward academics. Other things, though, are unobserved only in the technical sense that they are not included in the model. Okay, this is actually where it's important to think about regressions with controls. Controls in regressions try to reduce the problem. Okay. Any explanatory variable that is included in the regression. Remember on Wednesday I talked about having multiple explanatory variables in the regression. And I said those other explanatory variables effectively control for differences in those regards. Okay, so once we include them in the model, as opposed to being unobservables, then they are, once we include them in the model, they are no longer unobservables. They have been controlled for, and they are no longer a problem. So again, like if I include as additional explanatory variables experience and education when trying to predict women's wages, they are not unobservables. Okay? This is going to be a reason, I'll talk about it next week, why we want to put control variables into our models, like include control variables when trying to estimate effects. Okay, now, okay, the fourth thing on my list of why do we have correlation between X and Y? Aside from the primary thing that we're interested in, the effect of X on Y. So it could be that some combination of the values of X and Y impact inclusion in the data. Okay, and I call this selection. Okay, so let me do an example. Okay, talk about foods. Y'all know I have kids. When my kids were young, there were certain things they didn't like to eat. Okay, and so they, I'd be like, eat your Brussels sprouts. And the kids would be like, no, they taste bad. And I'd repeat what my grandmother told me. If they taste bad, that's how you know they're good for you. Okay, so it's true, right? We observe a negative correlation between the tastiness of food and the healthiness of food. Things that taste better are unhealthy. Things that taste bad are healthy. Okay, this is just terrible, isn't it? Right? Someone's really messing with us by tempting us with all these delicious, unhealthy foods. Or maybe not. Let me suggest that this could be in part a matter of selection. Okay, so imagine food has these two dimensions to it, healthiness and tastiness. And I wish I had more time. Okay, can you give examples of foods that are actually healthy and tasty? Do they exist? Apples? Okay, I'll just put them up in this quadrant for healthy and tasty. What else? Mangoes?
You say fruits that are just healthy and kind of tasty, or?
Healthy and tasty. Yeah, they need to be both. That's all. What?
Sweet potatoes?
Okay. Sweet potatoes. Let me see. Apples, mangoes, broader category is fruit. Right? No. Let's see. Healthy and tasty. Oh, we've got this bottom right quadrant. Things that are unhealthy and tasty. Examples of those. What's unhealthy but tasty? Candy, fast food. What else? Popcorn. I'm going to say popcorn is iffy. Cookies. Okay. Fried anything, right? If you go to the state fair, you'll discover anything tastes good if deep fried. Okay, so we start coming up with candy, fast food, cookies, fried foods. Those are all unhealthy and tasty. Now, let me move to another group. So the nasty tasting things that are healthy. Okay, what belongs in this top left box? Brussels sprouts. Okay, don't even defend Brussels sprouts around me. My wife is like, well, if you cook them in bacon and, cover them with salt and all. I'm like, yeah, bacon. Adding bacon to anything makes it taste good, but moves it into the unhealthy category. Okay, Brussels sprouts. Okay, other things that are healthy but taste bad. What? Blanking. Beets, the red things. Again, my wife will defend beets, but you and I agree that they taste like dirt, right? Okay. Yeah, beets. One time I had some students say, my mom's cooking. So I'll write Aaron's mom's cooking. Okay. Right? And I emailed her about that, and she said, I'm a doctor, I'm busy, they get something healthy for dinner each night. I'm like, fine. Okay, I'm sure it's low sodium, everything else. Now, okay, we have one final category. Can you all hang on for 1 minute? The things that taste bad and are unhealthy. Foods we eat because they taste bad and are unhealthy. This is going to be rough. Okay, fine. I'll put this on hold until next week, okay?